Hey mathematicians, we are going to go into graphing linear inequalities today in our topic of algebra. So, linear inequalities are going to differ from the linear equations that we studied previously. A linear equation might look like this, and when it's graphed, we are going to have some sort of a line graphed on our coordinate plane. Linear inequalities are going to differ in that here we're going to have a less than, greater than, less than, greater than or equal to, or less than or equal to symbol here, which is going to change how this is graphed. And what's going to happen is either the line itself is going to be part of the answer, the solution, and half of the graph, or the line won't be included in the answer and only half of the graph will be included in the answer. So we'll go into how all that works in a moment. So to start off, we want to think about what it means on a number line. So when we have a number line and we say x is less than 4, we know that we use an open circle on 4 because 4 isn't part of the answer. X isn't also equal to 4, it is just greater or less than 4 in this case, one or the other. So we would graph this, x is everything that is less than 4, and it would look like this. Okay, and the same thing, if it were greater than, we would use that open circle. So in graphing lines, we use an open circle for less than and greater than. And then if we're talking about graphing, do that again, graphing this, we use a closed in, filled in circle, because this time x is everything that is less than 4, but x is also equal to 4. So 4 is part of the answer. And then, of course, everything this way would also be part of the answer. So when we're talking about less than or equal to and greater than or equal to, we are talking about filling in that circle because 4 becomes part of the answer as well. All right, so how we can kind of translate into this other world is this. When we have a linear inequality, it's similar. If we have that equal to part, then we graph a solid line, and the line itself, every point on that line, is part of the solution. This is an example right here of something that's going to be also equal to, right? Then if we have a less than or greater than symbol, then we would use a dashed line. So this would actually be, this line would look like this, and the line is not part of the solution, so we would graph this line as a dashed line, meaning it's not part of the solution. Everything on one side or the other is, but the line itself is not part of it. It's very similar to what we do here. So in linear inequalities, we used a dashed line to indicate that the line is not equal to, just like the number wasn't equal to when we were doing graphing on just a number line. All right, so let's go ahead here and look at this first graph to see how we would figure out what the equation, or in this case inequality, is for this graph. Okay, so we know some things to be true right away. We know that because this line is solid, we are talking about either this or this. We don't know which one yet, but we know that it has the equal to part because the line is solid. And then we can use some of the knowledge we have from linear equations to come up with the equation of the line. Now, we're not going to know the symbol yet, but we do know that the y-intercept b is 3. You can see that graphed right here. And I can figure out the slope as well. So I can go from that point, I'm going up 1. So I know my slope has a numerator that is a positive 1. So that's my vertical movement. And my horizontal movement is 1, 2. And that's also in the positive direction. Up is positive and right is positive. So I might know my slope is 1/2. So now I can draft the rest of my linear inequality here. And that's a positive 3. So that's what the equation of the line would be if it were just a line. But because it's an inequality, now I have to determine which side of the line is graphed. And I have to determine what my symbol is. I know it's going to be one of these because the line is solid. So what we do here is we take any point on the solution side and we test it out. We fill in the x and the y, and we test it out. We call it a test point. So I'm going to take 2, 6, and it can be any point that's on the solution side, the highlighted or graphed in side. So I'm using as my test point, I'm going to use 2 as my x and 6 as my y as my test point. Now I'm going to plug in those values. So let's, again, we don't know what that symbol is yet, but we're going to figure it out based on what this says to us. So 2 here as my x, 6 is my y, and now I'm going to do the math. 2 over 2 is 1. 1 plus 3 is 4. And now I can fill in the symbol based on what this is telling me. 6 is greater than or equal to 4. So that is the symbol I will use in my inequality because plugging the point told me that that is the correct symbol. Now we could have used a different point. This will work with any graphed point. So let's pick up another one just to try it again. So let's this time try, let's see, -4, +4. So let's try this test point. And again, any one of these will tell you what the symbol needs to be. So for my y, I'm going to place 4 here. Again, I'm going to pretend I don't know and test this one. 1 over 2, my x is -4 plus 3. And then I'm going to do my math here. Again, this is unknown. 1/2 of -4 is -2. And then -2 plus 3 is 1. 4 is greater than or equal to 1. And again, check, check. So again, any point will work. You just have to pick one. All right, so let's continue on. Let's try one more of these. This one has a dashed line. So let's look at the things I know for sure right away here. First of all, I know that because it's a dashed line, that I'm going to be using either less than or greater than as my symbol. Less than or greater than because the line is not part of the answer. That's why it's dashed. I know for sure that my y-intercept is -3, and I'm going to count off my slope here. From that point, 1, 2, that's a +2 as my vertical movement, and 1, 2, 3, that's a +3 to the right for my horizontal movement, and now I can start forming the equation that will be an inequality, 2/3 x minus 3. There we go. Now, again, we're going to choose any point from our set of solutions that are the graphed highlighted side and use a test point to see what this symbol needs to be here. So I'm going to choose, let's see, 7, 1. So my test point's going to be 7, 1. Let's try it out. So x is going to be 7, and y is going to be 1. All right, so we have 14/3 here, minus 3, and 14/3 is going to be, this is a time we want to change this into a mixed numeral, so our mixed fraction, so that we can do the math. So 14 divided by 3 is going to be 4 2/3. 4 2/3 minus 3 is going to be 1 2/3. And 1 is definitely less than 1 2/3. So this should be less than. Now, not a bad idea to put in a second point just to double check my work. Let's do that now. So let's try another point. Let's try 1, -6. Again, any point will work. So my x is 1. My y is -6. Don't know what that is yet. We're going to pretend we don't know what it is. So this is 2/3 minus 3. And -3, and then a positive 2/3 would be 2 1/3. -6 is less than 2 1/3, and again, that just verifies that we have our answer here. And the final inequality, linear inequality, is y is less than 2/3 x minus 3 will result in this graph. So now we're going to do the opposite process. We're starting with the linear inequality and we're going to graph it now. So let's think about things we know for sure. First of all, we have y is less than, no equal to part there. So we know for sure that that line is going to be dashed. We also know that the y-intercept is -4. And we know our slope is positive. It is a 2/1. And now we can start graphing. So we go back to the knowledge we have of linear equations, and let's go ahead and get our y-intercept graphed. And from that point, we can start counting off our slope. We have a positive and a positive, so we're going to be going up and we're going to be going right. So let's count off that slope. 1, 2, 1. That's another point. And I'm just going to do one more just to make sure that our line's nice and straight. 1, 2, 1. There's another point. 2 points will do the trick, but having another one's not a bad idea. And now we're going to make our dashed line. So our line is here. And of course, you should be doing this with a ruler to make sure you have a nice, accurate, straight line. All right, there is our dashed line. So which side of this includes all of the answers or the solutions to this inequality? Well, the only way to find out for us is to test a point. So I like to use 0, 0 because it's so easy. I like to use the origin. As long as the line's not really close to it, I like to use the origin. So this point is either going to make this statement here true or false. If it makes it true, that means that this side has all of our solutions. If it makes this statement false when we plug it in, then it's the other side that contains all of our solutions. So let's go ahead and do this. 0. And see how easy this is. 0 is less than -4 because that turns into 0. Is 0 less than -4? That's a no. Okay, so it would appear that this is the side that needs to be highlighted and graphed in and contains all of our solutions. But it's not a bad idea to do one more test point on the other side and make sure that that makes our statement true so that we're sure we're on track. So let's try 5-1. 5-1 is definitely on the other side of the line. Let's go ahead and plug that in. So our x is 5, our y is 1, and this should make our statement true. So that's 10 minus 4. 1 is less than 6. That is true. That's a yes. So that means that everything on this side of the line, not the line itself, the line itself is dashed, so it is not part of the solution, but everything on this side of our graph here and on forever in this direction is a solution. Every point contained is a solution. We can plug any one of those points, x and y here, and it will make this true. So now it's time for check and correct. So what I would like you to do here is to first write an inequality for this graph, and then also I would like you to graph this inequality. All right, so at this point, you can stop the video, do this work, and then start the video again and check and correct. Welcome back. Hopefully you have a graph here and a new inequality that you have written for this graph. So let's begin with this graph. So again, what do I know for sure here? I do know it's a solid line, so I know my symbol is going to be one that includes that equal to part because the line is part of the answer. I also know that my y-intercept, or b, is -6. And I know that my slope is, I'm going to count it off, 1, 2, 3, 4. So it's a +4, as is up. Does not look like a 4. And it is a +1 over. So my equation for my line, before I can add in that inequality, would look like this. And now it's time to figure out what the symbol is. And what we do for that is we pick out a point on the graphed side and use it as a test point. So I'm going to use 4-1 as my test point and see what it tells me to do with the symbol here. So let's plug that in. So I have 4, my x is also 4, -6, don't know what this is yet, but my y is 1. So I have 4 times 4 is 16, -6 is 10, and 1 is less than or equal to 10. And the reason we want to be clear about which symbols we're going to be using right away is that way you don't make a mistake here and just say less than. You want to know what your symbols are going to be. That line is solid. You have to have the equal to part. So our final linear inequality is y is less than or equal to 4x minus 6, and that is the graph of this line and the side of the coordinate plane that contains all the solutions. All right, now we're going to go into the second part of this, which is graphing a line. Let's do that. All right, so we begin with our y-intercept at 2. We're going to count off our slope. These are both positive, so we're going to be up and to the right. So up 2, right 3. 1, 2, 3. And there we go. Now, what kind of a line do I have? I have a dashed line because it is not the equal to symbol also. So I'm going to freehand this dashed line. Again, you should be using a ruler so that your work is accurate and precise. And there's my line. Now I'm going to use my test point to figure out which side of this dashed line contains my solution. So I'm going to use the origin because it's easy. The line isn't right on top of it, so it's a good point, nice and easy to use. So 0 here, 0 here. So is 0 less than 2? It is. And that tells me that this side of my line is my solution. So this would all be part of the solution here. Everything up to but not including the line. Again, if you want to do a second test point or you want to test a point on the other side, you can do that just to make sure you're on track. So we could use 1, 6 and test the other side just to be sure. So we could use 1, 6. So 6 as my y, 1 as my x, plus 2, 2/3 plus 2 is 2 2/3, is 6 less than 2 2/3. That is a false statement. That is a big no. And that just helps me to confirm that that is not the side containing the solution. This side is the side containing the solution. All right, so now you're going to do this problem on your own. So again, like last time, the first thing you're going to do is to come up with the equation, the inequality for this graph, and then also you're going to graph this inequality. And there you have it. All right, thanks so much for stopping by today. And as always, peace, love, and pie to all. Bye-bye.